In any vehicle with suspension and steering, rotation must be transmitted to the wheels, even when the shafts operate at an angle. But if we look at a simple joint, something goes wrong. The output speed is no longer constant. This leads to vibrations and energy losses. The solution is the constant velocity joint. This mechanism is specifically designed to transmit rotation through varying angles while maintaining a constant output speed, something a conventional shaft simply cannot achieve. On the outside, we have the housing connected to the wheel. On the inside, the inner race connected to the transmission. These two components can articulate relative to each other, but on their own, they cannot transfer rotation. That's where the balls come in. Each ball sits inside a groove in the housing and simultaneously engages with a corresponding groove in the inner race. As the angle between components changes, the balls slide within these grooves. At this point, it seems the mechanism can already transmit rotation at any angle while keeping a constant speed. But why does it actually work? Notice that all the balls remain aligned within a very specific plane. This plane exactly bisects the angle between the input and output shafts. The grooves in both the housing and the inner race are precisely shaped so that the balls can only occupy positions within this plane. For every possible angle, there is only one valid configuration. So when the inner race rotates, the balls are forced to transmit motion through this bisecting plane. And because that plane always divides the angle equally, the output speed remains constant. To ensure this condition is maintained at all times, one final component comes into play: the cage. The cage keeps the balls evenly spaced and prevents them from drifting out of position. Working together with the grooves, it ensures the balls remain correctly aligned at all times. Now let's see how this works inside a vehicle. The constant velocity joint is part of the axial shaft that connects the transmission to the wheel. Each driven wheel uses two joints: an inner joint connected to the transmission and an outer joint connected to the wheel. When we turn the steering wheel, the wheel changes direction. This creates an angle in the outer joint. At the same time, the suspension moves the wheel up and down. This changes the distance between the wheel and the transmission. As a result, the axial shaft must be able to change its length, and that is exactly the role of the inner joint. So the wheel can rotate while simultaneously moving vertically. And even under these conditions, engine power is transmitted smoothly, without interruption and without variations in speed. This is possible because both joints are constant velocity joints, each solving a different problem. And that concludes the explanation of the constant velocity joint. Thank you so much for watching.